Good morning and a warm welcome to all the respected professors, speakers, and participants who have joined in. I am Sakiba Nabi and I'll be moderating the session today. As always, I would request all of you to keep your mics and videos off during the session to avoid any sort of unnecessary disturbance. Our first session today will be by Dr. R.A. Christian, who would share his knowledge about fuzzy logic, fuzzy rule base, and its applications. Dr. R.A. Christian is a professor in the Civil Engineering Department of SVNIT Surat. The major areas of his research include fuzzy logic application, particularly in the field of environmental engineering. He did his PhD at SVR College of Engineering and Technology, Surat, after which he has worked on several projects related to fuzzy logic. He has many reputed national and international journal papers attributed to his name. We are much obliged to Dr. Christian for sparing his time for today's session. I would now like to invite Dr. R.A. Christian to start the session. Please, sir.
Thank you very much for your kind introduction. I see that there are almost around 42 participants who have already joined in
Yes,
for
sir.
this session. Yeah.
Yes, sir.
And at the outset, let me first thank the organizers for giving me this opportunity, this precious time to share something related to fuzzy logic and its application to the field of civil engineering and particularly to the field of environmental engineering. So before I begin my presentation and share the presentation with you, uh, is there anyone who has some idea about fuzzy logic from the participants? I'm asking.
Okay.
Anybody who has some idea? Yeah. Huh. I would like to know that what knowledge the audience has so far as the fuzzy logic is concerned. Yeah.
Okay, any of the participants, if you know anything about fuzzy logic, please have a conversation with sir.
Okay, so I think this is a new area for almost majority of the participants because nobody has responded so far. So
Yes, sir.
let us take it that they don't have any idea about this. So my lecture basically is going to be a very preliminary lecture to make you develop your interest in fuzzy logic so that you can use this as a tool in your research program or any project, whatever you would like to do in the future. So that will be the objective of this very introductory sort of first session, I would say, on fuzzy logic. Okay, so with this understanding, let me project to you the presentation. Let us see if you are able to view this presentation. I am not able to share this. Sorry. Why is it not getting shared? Can you just help me with this?
Sir, you just need to click on present now.
I have done that.
And then you need to click on the
present now.
Yeah, then you have to
A window or
Yeah.
whole. Okay, a window.
Okay.
Yeah. Right.
And then
Yeah.
you will see
I
when you
share.
open the Okay.
Okay.
Did you?
Are you able
Yes,
to
sir.
see this?
Yes, sir. Yes, sir. Now it's visible.
Okay. So I'll go to the presentation mode. Okay.
Yes, sir. Yeah, please.
Okay. Is it visible now to you?
Yes, sir. Yes, sir. It's visible.
Okay. Unfortunately, my Windows need to be activated. It is a new PC, so you'll have to bear with this. Activate Windows.
That's absolutely no issue. That's absolutely no issue.
Okay, fine. So this is a short lecture on fuzzy logic, fuzzy rule base, and its application. A very simple lecture to make you understand and then to develop your interest in fuzzy logic and how you can, model various problems, life problems and situations using the fuzzy rule base. And I'll share how we applied this fuzzy rule based technique in one of the research project which I did for the Kakrapar Atomic Power Station, sponsored by Department of Atomic Energy, DAE. So this is going to be the way we will be going through for this 1.5 hours of this presentation. Now, uh, fuzzy logic, when we talk about the question is it really fuzzy? Is it really very difficult to understand? The name itself, as you know, fuzzy, something which is not clear, or which is not distinct, or which is not very precise, that we call it to be a fuzzy thing. Okay, so fuzzy logic deals with something like that, which does not have distinct, clear boundaries or precise boundaries. But actually, that is what we do not need. We do not need any very specific or clear or distinct boundaries. We can do a lot with or with indistinct or not very clear boundaries. Still, we can do a lot of modeling and all that in our real life problems. So the fuzzy logic, really, it's very interesting stuff to understand when we want to apply it to certain problems which we want to address in our real life situation. So that's what it is actually, the fuzzy logic. Now, fuzzy logic concept, as you all know, it's not a very old concept. It's just a recent concept which started somewhere in 1965. And the founder, or the person who conceived this fuzzy logic concept, was Lord Fizade. He passed away last year, or maybe before that. But a professor at Berkeley
Just a
University of
second, sir. Just a second. Sorry for interruption. Can you
yeah,
please stop presenting and then start presenting again? There has been a technical issue.
I need to stop it and then start again,
Okay,
is it?
okay, done. No, no, no. Okay, now it's clear. Sorry. Sorry for the disturbance.
It's okay, fine.
Yeah, it's fine. Just
Okay.
continue. Thank you so
Okay.
much.
I can also tell the participants, if you are not able to understand at any point, you can interact, or later on you can ask the
Yeah,
questions.
yeah. I
Whatever. Yeah.
we have mentioned in our rules that they can message the queries and questions in the chat box, and after the
Okay.
session, we will transfer all
Oh,
the queries to you.
sure. Okay.
Thank you, sir.
So,
Please
okay,
continue.
okay, fine. Lotfi Zadeh was a professor at the University of California who introduced this concept of fuzzy logic in 1965. Not a very old concept, but it has dominated in this short time. It has dominated in almost all the fields of engineering and sciences. And it is basically a way of processing the data that we have nowadays. We have a lot of data available with us. So processing the data by allowing a partial set membership rather than the crisp set of membership or non-membership. So fuzzy set theory. It's a set theory, basically. Fuzzy logic, the word and everything comes based on a set theory, which is different than our conventional crisp set membership theory, which we have all studied so far. That means a particular person may be a member of a particular set or may not be. So that's very crisp. Either you are a member or you are not a member. So that's a conventional set theory. But the fuzzy set theory, it allows partial membership. That's an interesting component that has been added by Professor Zade. Now, if we compare this traditional binary set, which is a set which is, as I said, a crisp set theory, which can have uh, either true or false. The statement can be true or false, no in between. But fuzzy logic variables may have a truth value that may be ranging in degrees between 0 and 1 because it's partially true. So partially true values, false value may have 0 and the true values may have 1. That is the conventional set theory. But in the fuzzy set theory, we have the uh, intermediate values also that lies between 0 and 1, which are because the statements can be partially true also. So the truth value in this fuzzy set theory may range between completely true and completely false. That is, as I said, between the values of 0 and 1. So partially true statements lie definitely between 0 and 1, depending upon the truth of the statement. That's the charm of the fuzzy logic. Now, it is the logic underlying the modes of reasoning which are approximate rather than exact. Now, partially truth means it's not crisp, it's not exactly true or exactly false. It's partially true and partially false. So this concept of the things taking the things rather approximately rather than crisp. And in our day-to-day life, I'll show you a lot of cases where we don't need exactness of aspects to come to a decision. We don't need crisp values in our day-to-day life. As Professor Zade is it said here, he reasoned that people do not require precise numerical information inputs. We don't need certain precise information inputs, but still we can take our decisions quite. Mm, we are capable of taking decisions at various point of time in life, though we do not have very precise information with us. But still, we are able to take quite a good decision over the period of time. Say, for example, if I ask you, can you lift this animal? It is obvious that your answer would be no. You would not say and tell me that I can answer this question, sir, only if you tell me the exact weight of this animal. So you never wanted to have any information about what is the weight of this animal. You very logically said that no, it cannot be lifted. So there are a lot of instances in our life, day-to-day life, where without even precise information, we are able to take a lot of decisions. Like, for example, if I ask you, will it rain today? You'll just look at the sky and say, oh, there are no clouds, sir, it won't rain. You don't need precise information that what the atmospheric conditions are or whatsoever. So, in our day to day life, there are a lot of instances where we don't need precise information to take decisions and to come to certain conclusions in life. So this concept was used by Professor Zade to develop this beautiful concept of fuzzy logic. Now, the question is that why fuzzy logic was ever needed or required when we had already a set theory in place. Why this fuzzy logic type of set theory was required to be introduced? Now, as we all know, our human knowledge is fuzzy. We don't have complete knowledge of all the systems that we are surrounded with. They are all fuzzy. They are incomplete in knowledge. We still yet to explore a lot about our universe. We still need to explore a lot about our environment. We still need to explore a lot about our ecosystem and a lot of things. Whatever system you are dealing with, the knowledge is not complete. It's still fuzzy. It's still hazy. So the human knowledge is fuzzy, expressed in uh, linguistic terms many a times. Like, for example, if you look at me and if you don't know my age, you will say that he's not a young man. He is an aged person. If you look your classmates, okay, he is young. If you look at a child, you will say that okay, he is a child yet. So looking at people, looking at the system around you with that fuzzy knowledge also, you are able to, you know, talk in terms of linguistic variables. And we do that a lot of times. We do talk in terms of the linguistic variables. We don't go with the actual values, so as to say, to mention certain things. Like, for example, temperature is expressed as cold. You don't need to say that it's 7 degree cold. You don't need to say that it's -5 degrees very cold. You simply say it's very cold, or you simply say it's cold. You simply say it's hot. You simply say it's warm. We don't need to put in the exact, numerical figure to quantify a particular thing which you want to express. As this discussion is going on, you can understand very well that in our day-to-day life, we don't deal with numbers. We don't quantify things. We deal with a lot of things in our day-to-day life which can be expressed in terms of linguistic variables. And that is where the fuzzy logic plays an important role. And that is what we are actually doing. My dear friends, we are actually dealing with a lot of fuzziness in our life without going into the precise detailing of the various aspects that we experience in our life. That's where the fuzzy logic is important. That's why fuzzy logic is important in our day-to-day life to address different issues and different problems which we try to analyze and understand. This is the fuzzy logic that we are talking about. Now, the importance of this fuzzy logic derives from the fact that most modes of human reasoning, and especially common sense reasoning, are approximate in nature. So, our reasoning, as I said, looking at that elephant, you very rightly reasoned out that no, I cannot lift it. So, these are all very approximate. What would be the weight of a bag in lying in front of you? So, with your common sense, with your understanding, you would roughly give some approximate numerical value to weight of a bag, or a weight of a person, or the age of a person. By human reasoning, we do a lot of approximation and reasoning, and we arrive at some numerical values. That's what we are doing in our day-to-day life. Therefore, developing this fuzzy set theory from conventional uh, bivalent set theory, in the sense that absolute truth and absolute false, only two values, either zero or one, bivalent set theory. It's a paradigm shift. So bringing in the concept of partial belongingness or partial truth is the gist of bringing in this all approximation in the set theory, and it gives very beautiful results which we'll see after understanding what actually this fuzzy logic is. Now, something about fuzzy numbers. When I have tried to explain how a fuzzy number would look by saying that this is a fuzzy number 2. Now, when I say uh, integer or real number 2, you have a very clear idea that what is number 2 in mathematics or algebra. But when I say fuzzy number 2, I may define my fuzzy number 2 as ranging from somewhere about 2 के आसपास, ऐसा हम बोलते हैं ना. Suppose you want to give timing to some person, you want to go and meet him, then you would say, अरे यार मैं करीब 3 बजे के आसपास आऊंगा. Abdul Sir said that we'll start somewhere around 9:30. Not exactly 9:30, maybe 9:35 or 9:25, 9:40, like that. So that fuzzy number 2, as per my definition, here as this case shows, I define fuzzy number 2 as ranging from somewhere around 1.5 to 2.5. That's my definition. Your definition may be that fuzzy number 2 ranges from 1 to 3. Any other person would define 1.75 to 2.75. So every decision maker has its own freedom to define fuzzy number two. So, in contrast to our number two in a crisp set theory, as we discussed earlier, two means two, either two, not more than two, not less than two. Two is two. Only two has one numerical value truth of one. 2.9, no. 2.1, no. 0, 0, everywhere. But here, the numbers from 1.5, as we see in this picture, 1.5 has the truth value of 0 as it is on the x-axis and y-axis intersection. So is 2.5. It has got 0. But as you go towards to that belongingness or the truth, it increases and it becomes exactly 1 at number 2. This is how the fuzzy numbers work. And believe me, you have a lot of mathematics based on these fuzzy numbers. Only thing is you have to explore how fuzzy numbers can be, added, divided, subtracted. A lot of mathematics is there. But that's the difference. That's the difference between what is a number two, real number two or integer number two, and what is a fuzzy number two. And whole set theory and whole mathematic theory is there on this numbers, fuzzy numbers. Now let's understand something about what we call linguistic variables, because when we apply this fuzzy logic using rule base, we'll be working more with these linguistic variables. Let me explain to you that what are linguistic variables. Normally, the variables in mathematics, they usually take up the numerical values. In fuzzy logic application, non-numeric linguistic variables are also uh, sometimes used. More majority of the times they are used to facilitate the expression of rules and facts. Like for example, what is a linguistic variable? Like if you want to define beauty, beauty of a woman, beauty of a girl, how do you quantify beauty? There is no way of quantifying beauty. Intelligence, how do you quantify intelligence? Of course, there are a lot of tests that you do, to give it a numerical value. But he is very intelligent. He is a moron, or uh, she is very beautiful girl. She is not beautiful at all. So these are the words which we use to quantify certain terms like beauty, like intelligence, as I gave you the example. So in our day-to-day life also, as I said, temperature of cold and hot, like what we were talking about, you know, we use lot of linguistic variables. Now you all must be driving vehicles, So when we talk about the speed with which you drive 0 to 100, if you have a four-wheeler, if you are driving at 100 kilometers per hour, you can say that you are going at a very high speed. If you are driving at say 35 kilometers per hour, you can say that I'm driving at very low speed. Then you have many other linguistic variables which can be used for speed. Very low speed, medium speed, high speed, very high speed. This is how people use the linguistic terms to define the real life situation. Correct? So there are a lot of examples which one can give as such about this. Now, you must be wondering about these triangles and the blue lines which are there, which defines the fuzzy set high. Suppose say fuzzy set high. Then fuzzy set high varies from 50, 60, 70 to 80. So a person driving at 50 to 80 kilometers per hour is driving at a high speed. Again, as we all know, for this fuzzy set high, hmm, less than less than 50 or even 50 has the truth value 0. As you go towards uh, uh, this 60 kilometers per hour, 80, it has again 0, because then it goes to the set of the very high. So this triangles, whatever I have tried to explain here, it is up to the decision maker to define these sets. So the freedom is totally up to the decision maker. You are the decision maker, and you have the freedom to decide this fuzzy sets of speed that you want. And then that will be used in modeling certain uh, problems which you are trying to find a solution for. So this is how the fuzzy sets with linguistic variables would appear and look like. Now, with this understanding, let us come to uh, the fuzzy rule-based system. Uh, I hope I am not going too fast. Are you able to
No, sir.
understand?
No. Yes, sir. Yes, sir. You
It's
are
fine.
absolutely at a good pace.
Okay, okay, fine. Thank you so much. So, with this understanding that we don't need a very precise information, we don't need a very accurate system to model certain things and all that. Let us try to understand the fuzzy rule-based system. That is very important because the decision making, whatever we are going to do, some prediction model or decision making, that is what is reasoning through the fuzzy rules, that is an interesting concept. Now, the fuzzy rule based system is so simple to understand that without entering into any complex mathematical modeling, I can still effectively uh, do the modeling of a system which I am interested to study. I don't need to enter into the complex mathematical equations, because sometimes, mathematical equations are very clumsy and very difficult to understand and to solve them. It's a real challenge. So that can be done by using uh, the fuzzy rules, and it is known as the fuzzy rule-based system, that is the FRBS system. Very popularly applied, two type of rule-based are there. One is the Mamdani model, which will be discussing. Majority of the researchers, they work with the Mamdani model, and then the Takaji Sugeno model is another fuzzy rule-based system model, and those who are interested can go in the depth of that model also to study if can be applied to your system or not. But I'll be explaining to you the Mamdani model clearly to understand what uh, decision making is. The reasoning, the reasoning is very important in our day-to-day life. And when I try to explain this, the decision making and the reasoning, I give you a very classic example of these two people. Very commonly appearing face, very popular face, Abhishek and Aishwarya Rai. Very happily married for now. You all know that, but the history, जब इनकी शादी होने वाली थी तो ऐश्वर्या वाज मांगलिक. तो अमिताभ बच्चन के घर में डिस्कशन हो रहा होगा, यार मांगलिक है, अभिषेक क्या करेगा, शादी करेगा इससे? अगर मांगलिक है मर गया तो फिर अभिषेक बोलेगा कि अरे पापा छोड़ो ना, ये वर्ल्ड ब्यूटीफुल वर्ल्ड ब्यूटी है, मिस वर्ल्ड है, ऐसी दुल्हन मुझे कहाँ मिलेगी? चलेगा मांगलिक है तो कोई से शादी कर लेंगे, लेकिन मैं शादी करूंगा तो इससे ही करूंगा. तो ऐश्वर्या के घर पे बोला होगा, यार अभिषेक तू इतनी, यू आर सो ब्यूटीफुल, अभिषेक इज ठीक ठाक है, क्या करोगे, इससे शादी करोगे? देन ऐश्वर्या वुड हैव सेड, अरे मम्मी छोड़ो, इज अमिताभ बच्चन फैमिली है. See, this is how we do reasoning in our day-to-day life. All those who are married, maybe they have passed through this phase. And if you are not yet married and looking to get married soon, I think you'll be passing through this phase of life very soon. Arriving to take some decision at some point of time by reasoning. There are lots of, pros and cons in making a decision, and to arrive at a suitable decision, you weigh them. You weigh them. And then finally, these two people, they decided, in spite of whatever, limitations they had and everything, whatever it was there, they arrived at a decision and got married, and then they are happily married ever after. So, in our day to day life, also, we apply certain rule based application, of course, without writing the rules, as you will be doing here, in fact. When we apply this rule based model, we'll be actually writing the rules, but we don't do that in our actual day to day life. But we still do a lot of reasoning whenever we arrive at a decision making process in our life. So that's the real life scenario, which is incorporated in a fuzzy rule based tactic, you know, to uh, model a particular system. Let's try to see, based on this, let's try to see what is a fuzzy rule based system and how it works. Nowadays we have a lot of mm, electronic appliances which use a fuzzy system, like you have a fuzzy system based uh, dishwasher, you have fuzzy system based washing machine for washing of clothes. You have smart TV today, mm, which adjusts the screen brightness with the brightness of the room. You have smart air conditioners that they change the temperature setting mode based on the condition of the temperature of the room. So let's try to take this example of a smart air conditioner and try to see that how it works basically. Now, the smart air conditioner as a machine, it works with application of number of rules which would be fitted into the chip of the memory in the uh, air conditioner. Now, this air conditioner has a sensor which would be uh, monitoring the room temperature. So the input to this smart air conditioner would be the temperature, which is sensor based temperature, which is measured by the sensor. And predefined values of the temperature uh, would be defined with different sets of fuzzy sets, linguistic variables like very cold, then cold, normal, hot, and very hot. These are the temperature definitions in the linguistic terms, which are predefined, as I said, by whom? Who predefines this? The decision maker, the one who designs this air conditioner. That decision maker defines these sets and puts it in the smart air conditioner machine. Now, let's see how this is going to be used as a rule based system. Now, this air conditioner, when you switch it on, the temperature will be sensed by that sensor, and that numerical value goes into the air conditioner, that chip, and then the temperature is sensed, and then it says that if the temperature is very cold, then it gives out a order that stop the fan. Then stop ho gaya fan, and then temperature becomes cold, then turn down the fan. If temperature is normal, then maintain the level. If temperature is hot, then speed up the fan. So the continuous input from the sensor applies these rules to take the action as required. And that is exactly what is going to happen. At a periodic time, when the temperature set changes, the rule base is applied, and either the fan is stopped, or the level is maintained, or the cooling happens. So this is how the rule-based system is going to work in a smart AC. So you need to prepare a lot of this type of rules which will help in the system. Okay. Now, in general, if we talk about in general, a fuzzy rule can be defined as a conditional statement. If you see here, if temperature is very cold, then stop the fan. This is a rule statement. So a fuzzy rule statement in general is of a form that if X is A, then Y is B. This would be the input part of it, and this would be the output part of it. So X and Y are the linguistic variables, as we have seen in the previous example, cold, very cold, hot, like that. And A and B are the values which are determined by the fuzzy sets. Okay. And on the universe of discourse, X and Y respectively. So universe of discourse is like the temperature of the AC machine is fixed to work between, say, 16 degrees to 13 degrees Celsius. So that's the universe of discourse. My values of the linguistic variable temperature will be varying from 16 degrees to 30 degrees. That's what I define. The decision maker defines. So it's up to you to define your set of range of values within which you want to design the system. So X and Y are the input and the output variables. A and B are the sensed values or the linguistic numerical values as determined by the fuzzy sets. Okay. Now, the fuzzy rule consists of two parts. That is the condition part that is known as the antecedent. If X is A is an antecedent. That's the condition. If temperature is cold, if temperature is very cold, temperature is hot, that's the condition. And the second part is then ke baad, whatever is there, Y is B, that's the conclusion part, that's the consequent part. So the consequence is based on the antecedent. Okay. So any statement, a rule-based statement, whatever we define, is having an antecedent and a conclusion or a consequence. X is A, antecedent, Y is B, consequent. That is to say that if conditions or the antecedents, then the action or the consequence. If this, then this. Antecedent, consequent. This is how the rule base are formed. And fuzzy rules, they relate to the fuzzy sets. Their antecedents and the consequence, whatever we are deciding, that is based on the fuzzy sets. The input values goes in from the fuzzy set. I'll explain this to you by another example, which will take up shortly. But this is how the fuzzy rules are made, and the antecedents and the consequences are framed to model a system. Now, what's important is let's understand this. This is a very important concept to understand that in a fuzzy system, all rules can fire to some extent, or in other words, they can fire partially. If the antecedent is true to some degree of membership, then the consequent is also true to some degree of membership. You get the point? That means if I say these are the four rules applied here, if temperature is very cold, then stop the fan. If temperature is cold, that rule also can be fired. If the previous one is fired, then this rule also can be fired partially. And that will govern the output. Of course, the temperature cannot be hot at that time. That rule may not be fired. But very cold and cold both simultaneously may get fired. Partially, the rules can be fired. So, more than one rule can be fired. That's what's important to be understood. Now, I have shown you only four rules. You can have 80 rules, 200 rules, 250 rules, depending upon what sort of a system you are modeling. And in that case, depending upon the values which are taken up from the fuzzy set, that many number of rules can get fired. More than one number of rule also can get fired. That is important for you to understand that. And basically, how the output is derived at, I'll show you that also. One of the concept of the output I'll show you, because more than one rule gets fired, then how the output is determined. Now, if as we have seen, for example, a fuzzy rule can have multiple antecedents also. That is, multiple conditions can be there for a single rule, and one output can be there, or even multiple outputs can be there. In the previous example, we saw that condition was only single. It can be very cold, it can be cold only in one rule. But try to understand that it can have multiple conditions applied for the modeling purpose. Like, for example, I have given here that if the project duration is long, that is one condition, and project staffing is large number of people involved, that is the second condition, and the sorry, third condition, project funding is inadequate. So antecedent in this case has three conditions. This can also be a rule, and the output is then the risk is high. So the project duration is long, staffing is large, funding is inadequate, risk is high. This is one output, multiple antecedents. So a lot of this type of rule base can be created by a decision maker depending upon the inputs available to model the system. Okay, and it's very easy. It's not very complicated. It's not very difficult. It's very easy. Of course, MATLAB is one of the software which can do all this rule making and everything for you. Okay, but the concepts to be understood so that you can work with MATLAB and many other things to develop your own system. That's what I'm trying to do here, trying to explain to you. There can be multiple antecedents and multiple outputs also, consequences. Another example here in multiple antecedent is that conjunction which we are using. Previous case was and. We joined all these conditions with and. You can take this example of tipping a waiter. If you go for a hotel to eat, the service is excellent or the food is delicious, I'll tip the waiter generously. So here, the two conditions with one output is joined with a conjunction or. Now, and or in a set theory, the set theory has got intersection and union. So, and or acts like intersection and union. When two sets are intersecting, you take all the conditions. So use and. If it's intersecting, union. If it is union, you use and. All the conditions are equally important. So that's how the conjunctions are used and or. Now here, if you notice this, that if the project duration is long, staffing is large, and all these rules which we have made, also considering the rules of cold and very cold and all that, in our conventional programming language, you have 5 rules to be applied. Each of these rules is connected with an else. If this, then this, else, if this, then this, else, this. But here, in this rule base, when we talk about fuzzy rule system, you know, there is no else. All the rules are evaluated. Whether the rules are getting fired or not, all the rules are evaluated at the same time. And they may be firing at different degrees, but we still are interested to see which are the rules that fire. In our conventional programming language, if one rule is fired, then there is no need of applying the remaining else systems. It still directly goes out of that loop and goes to proceed with the further calculation. But that's not the case here. These rules are not connected with else. And that gives it a beauty that it checks in all the rules which you have formed. And it gives chance to all the rules to get fired. And then finally, the output is measured and output is evaluated. That's the beauty of the fuzzy rule based system. This is to show you that